Linear regression. Now, linear regression is a supervised learning algorithm used for predicting a continuous target variable based on one or more input features. It finds the line of best fit, which is also called as linear relationship, by minimizing the sum of squared differences between the actual and predicted values. Let's see how we can implement or have a simple implementation using scikit-learn in Python. So I'm going to open my code editor. I've already created a file called as linear regression.py, and I'm going to go one step at a time. So let's start with importing necessary libraries. So I'll need first from sklearn.linear model import linear regression. This imports the linear regression class from scikit-learn's linear model module. This class is used to create a linear regression model for predicting continuous target values. Next, from sklearn.model selection, import train test split. This imports the train test split function, which is used to split the data set into training and testing sets, helping evaluate the model's performance on unseen data. Next, from sklearn.metrics, import mean squared error. This imports the mean squared error function, which calculates the mean squared error MSE between actual and predicted values. MSE is commonly used to evaluate regression models where lower values indicate better performance. Next, import numpy as NP. This imports the numpy library, which is a fundamental library for numerical computations in Python. It's commonly abbreviated as NP. Next, let's get some sample data. In this particular case, we can get house size versus house price. So I'm going to create an array x equal to np array and give some numbers inside it. If you look at it, this is based on the house sizes in square meters. So this defines the feature data x as a numpy array where each element is a list containing a single number representing house size in square feet. The shape of x is 10, 1, meaning there are 10 example rows with one feature column. Next, let's do for y, and this is y equal to np.array, and I've added some values which are house prices. This defines the target data y as a numpy array containing house prices. Each value in y represents the price corresponding to house size in x. So that's what this is. Now, next step is to split the data into training and testing sets. This can be done using that function that we imported, which is train test split. And in here, this line kind of splits the data into training and testing sets, where we get x train and y train, which are the training data which the model uses to learn. And then we also have x test and y test, the testing data, which is used to evaluate the model's performance. We have specified the test size as 0.2, which specifies that 20% of the data should be used for testing and the remaining 80% for training. We've given a random state of 42. Now, this sets a random seed for reproducibility. The seed ensures that each time you run this code, the same split of training and testing data is generated. Next step is to initialize the training model. We can do that by saying model equal to linear regression. This creates an instance of the linear regression class, which represents a simple linear regression model. Then we're going to fit the model. So fit the data into the model. This trains the model on the training data x train and y train. During this process, the model learns the relationship between house size and price by finding the best fit line that minimizes the error in predicting y train from x train. Now, using this, let's make predictions. So to make predictions, I'm going to say ypred equal to model.predict xtest. Now this generates predictions for the testing set xtest. The predict method uses the trained model to output estimated house prices, which are ypred, for the house sizes in xtest. So once this is done, let's go ahead and evaluate the model. To evaluate the model, we'll use MSE, where MSE is mean squared error, y-test, comma, y-pred. Now, this calculates the mean squared error, MSE, between the actual values, y-test, and the predicted values, y-pred. MSE measures how well the model's predictions match the true values, with lower values indicating better performance. Next, let's go ahead and print these out. Print the mean square error and print the predicted values. Together, this code demonstrates a full workflow for training and evaluating a simple linear regression model in Python, from data preparation and data training to prediction and performance evaluation. So let's go ahead and run this code. I'm going to open my terminal or command prompt. Here, make sure we have that file. We are in the right path. I'm going to say Python linear regression.py. And there you go. We have the mean squared error of some big number and predicted values of for two different houses. One is 235,000 and the other one is 257,000. These are the predicted values. I hope you were able to follow along and understand this. If you have any questions or comments, let me know and I'll get back to you.